pretty just about difficulty level similar to yesterday, if not maybe a little bit easier. So yesterday we talked about inequalities in one triangle. So just looking at one triangle and the relationship between the biggest angle and the side opposite, which would be the biggest side, and so on. So today we're going to talk about two triangles and the relationships you can form between two triangles. So two theorems that you're going to copy down on Monday. And I need a pair of scissors. Okay. So the first theorem is called the hinge theorem, and the easiest way to kind of show you guys is with a pair of scissors. So basically what the hinge theorem says, you have two triangles. They have two congruent sides, okay? So two sides that are congruent, and if you're looking at the included angle, okay? So what happens is if you look at this angle, okay, these two sides are congruent. What you're looking at is this opposite side, which would just be the distance between the tip of the scissors, okay? What happens here is as you open the scissors, which means this angle increases, notice that these lengths aren't changing, but as this angle increases, what happens to this side? It increases as well, right? So when the sides stay the same, if the included angle increases, the opposite side increases as well. So you can use this hinge theorem to say, okay, well, if you have two triangles with two congruent sides, whichever angle, included angle is bigger, that opposite side is also going to be bigger than the corresponding side in the other triangle, okay? So we can use this to talk about two different triangles and relationships that they form. So for this first one, if we want to write an inequality to show the relationship between LN and QO. Okay, now look at what we have here. We have two congruent sides because ML measures 4 and QP measures 4, so those are congruent. MN measures 7 and QP measures 7. So notice that I have these two sets of congruent sides, and they give me the included angle. Now it has to be the included angle, the angle in between them, okay? But notice angle M is 125 and angle P is 78. This is the bigger angle, okay? Since angle M is bigger, what I can conclude, since the sides I've created are congruent, I can conclude that LN is going to be greater than QO. Since the sides are congruent, that's the big thing. We're talking about the included angle, okay? Now, theorem 514 is just the converse of that. So it just says, okay, if I have these two triangles, and it kind of relates it instead, okay, if I have these two triangles that have two congruent sides, if this triangle has the longer side than the other one, this angle is going to be bigger than the other angle on the other triangle. It just is the opposite, okay? So we can use this to, kind of like yesterday how we figured out the range of what that third side could be. It's going to be kind of like that, where what I have here is I have these two triangles, okay? I have two congruent sides, so I have RU is congruent to TU, and I actually have a second congruent side. Remember the reflexive property? I have SU will be congruent to SU. And notice they give me the included angle on both of those. Now, what I'm looking at is the opposite side. So notice, the side opposite of the included angle here is 15. The side opposite of the included angle here is 10. So what I can conclude here is that what I'm looking for is x. If I start with, okay, this 5x minus 20. The side opposite of 5x minus 20 is 10. So if I wanted to compare that to 60, the side opposite of 60 is 15. That's bigger. So what it means, this is the smaller angle. So 5x minus 20 has to be less than 60. And we can use this to figure out what x could be. So if I add 20, we have 5x is less than 80. And divide by 5, we'd have x is less than 16. But here's the thing. If I just say x is less than 16, it means that x could be anything less than 16. Like 0. X could be 0 because 0 is less than 16. Problem, if I plug in 0, we'd have 5 times 0 minus 20, which is negative 20, which means that angle is negative 20. Can you have an angle to measure negative 20? No. So you have to figure out the lower limit, right? It has to be less than 16, but I also know that angle, that 5x minus 20, 5x minus 20 has to be positive. So 5x minus 20 has to be greater than 0. So then if I add 20, we have 5x is greater than 20, which means x is greater than 4. So the range for your x values would be between 4 and 16. That's what we're doing today. That's it. Okay? All right, let's get this put into your notebook. This should be page 75, section 5.7, and it is inequalities in two triangles. On that left-hand side, so mainly two things. So using the hinge theorem to relate to side lengths, and then using the converse of the hinge theorem to find a range of values for the variables. So we want to write an inequality to relate the given side lengths. Now, if there's not enough information, we will just write no conclusion. So number 1, let's draw a right triangle. So it will, of course, have a right angle. We'll call this triangle RST. And right next to it, let's draw an obtuse triangle. This. And we will call this triangle ABC. Now, to use the hinge theorem, you have to have two sets of congruent sides. So we will say RS is congruent to AB, TS is congruent to BC, and then angle B is 98. And finally, we want to write an inequality to relate RT and AC. So this is what your homework problems are going to look like. You're going to have the picture, and then it's going to say, okay, look at these two side lengths, RT and AC, and I want to state an inequality saying, here's what I know about RT and AC. Now, what you need to make sure of, if you're able to use the hinge theorem, you have to have two sets of congruent sides, which I do, and you have to have the included angle, which I do. This is 98, this is 90. Now remember, since that angle is the included angle, and since these sides are congruent, the larger angle is going to correspond with the larger side. So which is the larger side? Which is the larger side? AC is going to be the larger side. So there's a couple ways you could write your inequality. We could say that RT, smaller than the other one, right? So is less than AC. Or if we flip them around and said AC is greater than RT, that's fine. It means the same thing. Okay, number 2. Our first triangle is going to be triangle XYZ. And the second triangle is going to be ABC. Triangle XYZ, triangle ABC. We will say XY is congruent to AB. YZ is congruent to CB. Angle Y is 54 degrees. And angle C is 62 degrees. I want to write an inequality to relate XZ and AC. So the sides I'm looking at are XZ and AC. Now remember, the hinge theorem, you need two sets of congruent sides. which I have, but what's the problem?
There's an included angle for triangles.
Exactly. Angle Y, it is the included angle, right? See how you have the congruent sides, this angle in between them. But here, which angle would you need? You would need this angle right here to do the hinge theorem, which I can't. So all you would say is no conclusion. Questions on 1 or 2? Okay, the other ones, we're going to find the range of possible values for each statement. So let's draw a right triangle, our right triangle, and then a triangle below it, like this. Okay, we're going to say the left side of the right triangle is going to be congruent to the left side, that top left side of the other triangle. And then the bottom of the right triangle is going to be congruent to the bottom of the other triangle. The hypotenuse of the right triangle is going to be 15. And then this side right here is going to be 12. And then finally, this angle in the second triangle is going to be 4x minus 8. Now, I think typically what we've gotten really used to is just saying, oh, we're going to set them equal to each other and solve. But I don't know that these are equal. In fact, I probably know that they're not equal, right? But what I do know is I have these two congruent sides, and I have the included angle, okay? And I have the side, I know what the side is opposite of the included angle. So remember, if the side opposite of the included angle, if that's what I have, the bigger angle is going to correspond with the bigger side. So this right here, that angle is going to be bigger than this one. So if I want to find what x is, I could say, okay, 4x minus 8 is, how would you relate it to 90? It's small, right? Less than, because 12 is less than 15. So 4x minus 8 is less than 90. So we will add 8 to both sides. We have 4x is less than 98. Divide by 4, and it gives me x is less than 24.5. Remember, you say x is less than 24.5, x could be anything less than 24.5, like negative 100. X cannot be negative 100. That would give me a negative value for an angle. And angles can't be negative. So we also have to say, well, whatever 4x minus 8 is got to be bigger than 0, because it has to be positive because it's an angle measure. So to solve for x this way, add 8. We would have 4x is greater than 8. So x is greater than 2. So x could be any number between 2 and 24.5. Let's do one more of those. Okay, number 4. All right, we're going to have this little triangle here. This little triangle here. Okay, and then this left-hand side, let's make that congruent to the left-hand side down here. And then we're going to make the bottom congruent to this right side. Okay, let's say that that side is 7. This side is 9. This angle in here is going to be 3x plus 18. This angle over here is going to be 84. So notice to use the converse of the hinge theorem, we have to have two sets of congruent sides and the included angle and the side opposite, which is exactly what I have. So if I want to solve for x, we'd say, okay, well, 3x plus 18. This angle right here, the side opposite of this angle is 7. 7's less than 9. So 3x plus 18, how would you compare it to 84? is also going to be less than 84. So we subtract 18 from both sides, so 3x is less than 66. So x is less than 22. What else do I need to find? The minimum value. Because I know that 3x plus 18 has to be bigger than 0. Got to be bigger than 0. So if I subtract 8, x, 3x, not 3x, 18, there we go. 3x is greater than negative 18, so x is going to be greater than negative 6. Okay, and then last one. Yes.
So the x could be below 0.
X can be. Because notice, even if I plug in negative 1, it'd be 3 times negative 1. So this can't be negative. Yeah, good question. Okay, last one, and this is going to be a fun little picture to draw. Okay, I want you to draw 2 parallel lines. The bottom parallel line just a little bit longer than the top one. And then connect them to form a trapezoid. Fun word there. And I just told you they're parallel, so let's go ahead and mark them as parallel. And let's draw triangles here. So we've got kind of 3 triangles, and let's go ahead and label all the vertices. So starting in the top left and just working our way around, we'll do M, P, Q, O, and N. Okay, we're going to say NO is congruent to OQ. Both of these top angles here are going to be 45, which means that other angle is going to be 90. And then this angle over here is going to be 44. Now, that's all the information I'm given, but I might be able to find some other information. Based off this picture, is there anything else that I know? Elijah? So these 3 angles here together add to be 180. So 90 plus 44, subtract that 180, we would get 46 on that angle. Anything else? That maybe not. Gabby?
Angle QOQ is equal to angle
M O N. Now, actually, they're not. See how I have 44, 46? So they're not. And I need to look more at that because I'm kind of with you too, like something on those parallel lines. I think that actually they probably should be parallel. What about that middle triangle? What could you know about that middle triangle? If these 2 angles are 45,
It's an isosceles triangle.
it's an isosceles triangle, which means those 2 sides are congruent. Okay, so let's use that information. Okay, let's say if the measure of angle POQ, I want to compare that to the measure of angle MON. The measure of angle POQ, which they said was 44, how would you compare that to the measure of angle MON? Less than, right? 44, 46, less than. Yeah. Okay, number 6, using that information, MN, how would you compare that to PQ? MN, how would you compare that to PQ? It has to be right because this is the bigger angle. They have 2 sets of congruent sides, so the bigger angle is going to be opposite the bigger side. And last one, what about MP compare it to OP? This one you gotta think about. MP, how could you compare that to OP? I agree with that. MP is greater than OP, but how do you know that? Yeah, remember yesterday we talked about inequalities in one triangle that the larger angle, 90, is bigger than 45, which means that side is going to be bigger